Hi, I'm Terry Butchie from Ohio State Math Literacy Initiative, and it's been a while since we've had a video. We started putting together some videos for caretakers and parents at home, but also for teachers who wanted to learn a little bit more about different kinds of ways that you can teach mathematics with little to no materials, but be able to help out your student, whether it's your own child or a grandchild, sibling, or your own students at home. So since school's over, whatever that school looked like for you in the spring, as a group, the Math Literacy Initiative tried to think about ways that we could help to facilitate what's going to happen this fall, which we really don't know right now, but we do know that teachers and grandparents, sibling teachers too, can be pretty flexible, and that's what we are going to have to dig deeply into ourselves and try to figure out how can we make the best representations or best experiences for our students this fall. So one of the things that we thought might be helpful is talking about something called critical areas of focus. So as many of you know, I'm a professor at Ohio State University, so we work with the Ohio Department of Education as well as all the other universities in Ohio, work through Ohio Department of Education as well, and really helping to support teachers in using some of the resources that our Ohio Department of Education provides for us. So you might be from another state, but in Ohio we have these things called critical areas of focus, and your state may as well, and you can just Google it and see how your Department of Education addresses the critical areas of focus for your state. So I'm going to just show you what it looks like. So at Ohio Department of Education, there's a document that's called the Critical Areas of Focus. And let me just explain briefly what that is. It's really a tool designed for use by teachers to really, first of all, know what the big E ideas are in each grade level. The ones that, we teach a lot of things through every year in every grade level, but it's nice because Ohio Department of Education is giving us these big ideas of what it means to learn math in kindergarten, or what it means to learn math in 5th grade. Like, what are those big things? And the reason why we thought this might be really important, especially this year, this summer, is because we lost some instructional time. I mean, we were working with our students, we love our students, but it looked different. Everyone knows it looked different. So one of the things that we thought might be helpful was to bring to both teachers, if you're a teacher or a parent or a guardian or someone who works with students, just this tool, because we know that these are the big things that we want our students to have when they go into the next grade. So if they missed some instructional time, let's just kind of make sure that our students have at least like some foundational information in the big ideas for their year. So we're going to start this sequence, or this series, excuse me, with kindergarten. As I said, you can go to Ohio Department of Education or try your Department of Education. In Ohio, I have this math for K to 8. There are also critical areas of focus for Algebra 1 and geometry as well. So just kind of skim through it. There's a lot of detail in here. I'm just going to show you where we're going to start. So it has all the critical areas for each of the grade levels up to 8th in this particular document. We're going to start with kindergarten. And I'm showing it to you because sometimes we use words and it's not like a commonly used word, or we have another word that we use when we teach. And if you're a parent at home, some of these words might have different meanings for you. So there are 2 critical areas of focus in kindergarten. Many of the other grade levels have more than that, but as you'll see, while it's just 2 areas of focus, there are some big ideas in here for kindergarten. So the very first one is representing and comparing whole numbers. That's the first big idea that we want all kindergartners, when they go through kindergarten, and this is at the end of kindergarten, so please don't think your kindergartners come in knowing this. That's not it. The purpose is to make sure that if you have a kindergartner last year and they're moving into first grade for this next year, these are the ideas that we want to make sure every kindergartner going into first grade has at least some foundational understanding on. So the first one is comparing and representing whole numbers, which makes sense. Now, if you look at this, I'm just going to skim through here a little. So we have this first critical area focus. We just read this off. And then they have subsets within each of these critical areas. So the first one that we're going to talk about today is counting and cardinality. So counting and cardinality, what does that mean? What do some activities look like that they share with you so that you know a little bit about what they mean? But we're going to talk about it in kind of layman's terms as well. So then the next one, this is operations and algebraic thinking. That's also within this first critical area for kindergarten, but we're going to do that one on another session since counting and cardinality is such a biggie for kindergarten in particular. So what is representing and comparing whole numbers? It's looking at can students write their numbers? Can they identify their numbers? Can they identify their number by the written numeral or by number of objects and different ways of really understanding and making sure that our kindergartners have this particular area of focus. So we're going to go down, we're going to start talking about some of the different components in counting and cardinality, and then I'm going to give you some examples of some of those. So knowing your number or knowing the numbers names. Again, that means both with tactile materials, whatever kind of counter you want to use or that you have outside or around the house. You can use anything, but we really want them to be able to count by hundreds, count forward. We need them to be able to know their numbers from 0 to 20. And then we need to be able to count in a variety of different ways. I'm going to point to one word here. So there's this word array, which we'll talk about what array means when we get to the actual tactile numbers. But this is one of the big ideas in kindergarten. It's highly likely that your child's teacher, or if you are a teacher, that you did a lot of these at the beginning of the kindergarten year. So highly likely that your students didn't miss, if it's your child or your student, didn't miss this piece, but we're going to talk about it anyway. So I'm going to now switch over to, I believe, to our working document. All right, so now we're going to work on what these different things mean. So what does it mean for kindergartners to understand the idea of counting and cardinality? So one of the first things, and we did a session on this, so if you didn't see the session on the counting principles, this is where the counting principles come on. So one of the primary things that we want to make sure with the counting principles, and this is one that a lot of people know, is this idea of one-to-one. So when a child, a kindergartner, counts, because this is one of their critical areas, when they count, we want to make sure that for each item that they're counting only one item. Now it sounds like, well, of course they're going to count just one item. That's not necessarily the case. So we want to give them a lot of practice with actually counting these numbers. The other thing that's really important with this idea of counting and cardinality is the idea of cardinality. So you probably don't think about it as cardinality, but cardinality is when when you touch the last item that you're counting, that number, that last item that's being counted names the set. So in this particular case, I have little stones that we have. So we have 1, 2, 3, 4, 5, 6, 7. That means that there are 7 numbers in this set. Now, you're not going to have a kindergartner that says, that means that there are 7 numbers in the set. No, it just means we want them to know that if you ask them to count this, they say 7, and they know that that means that there are 7 stones down there on our paper. And we also want them to know, because this is these are the critical areas. So we want them to be able to write the number 7. So you want them to be able to write their number 7. Now, a kindergartner's number 7 isn't going to look just like that, but it'll be something that looks similar to a 7. You want it to be as close as possible. We also want them to be able to look at a number. So let's say we have this number here, 8, and we want them to know that they can both name this number 8 and then show us a set of 8 somethings. So I could say, could you show me a set of 8 stones? So, and you don't have to use the word set. Can you show me 8 stones? So what they might do is put a bunch of stones and count up 8. 1, 2, 3, 4, 5, 6, 7, 8. And this one doesn't count. That would be cool if they did that. Just put a bunch of them there. And then they would know that, oh, I have too many here. So if I have too many, and let them struggle with it a little bit, and let them know that they have the power to remove some of those stones from the board. So that's just recognizing and creating a number. So that tells us that they know when they look at it, and they can tell when they count them, both in items and in the numeral. So another thing that's important, and we can do it with these 2 numbers that we have here, is we want students to know, another big piece of one of the big counting principles, is we want students to know that the next number in the set, so if we have a number 7, just like we had here, we had this number 7, I'm going to make some arrays. Arrays are like these lines that we have here. So I have this number 7. I know this is number 7 because I counted it, and I wrote the number 7. So we know that our kindergartner knows 7. It looks like this as a numeral and like this as a set of items. And then you can say, okay, let's put another stone on there. So we're going to put this stone on there. How many do we have now? And so if your student counts them to find out how many they know now, they need to get some more practice with counting. And that doesn't mean they're doomed in math. It just means they need to have some more practice counting. If they start with 7, which at the end of kindergarten, many students will. If they don't, this is something that would be valuable to them. If they see a purpose in it, don't force it on them. But if they know this is 7, then they could say, well, 7, 8. That's a complex, abstract task for a kindergartner. So if they do that, hallelujah. But don't be too bummed out if your child doesn't do that right now. But one of the things that this critical area means is that they know that now 7 and 1 more gets us to 8. So they know that when we put 1 more onto this set, it gives us the next highest number. Now, that seems silly to us because of course it does, but for little ones, we're trying to get them to have this picture of the more. We have a number and we have a little bit more, and that little bit more is going to be just a little more than that last one. So if we have an 8 and we want to go to 9, we're going to add 1 more. So you can do this either going numerically with the written numbers or as the items. So now I'm going to add on 1 more. What do you think it would be? Maybe you don't write down the 9 at that time. What do you think it might be? But this idea of every time we add on another number, it gives us this bigger total. That's an important aspect. So we know that we have 9 now. Let's put this in an array. I'm going to have non-equal rows or columns here. So there's our 9. If we had 1 more, put 1 more stone on there, what do we have now? Well, and these are in an array for a reason. We want students to start thinking about arrays. So we have a 5 here and a 5 here. What does that give us? That gives us our 10. And what does that mean? That's 1 more than 9. So you might notice that we're starting to kind of develop what we commonly know as this number line. So we've so far done something like this. Now number lines are abstract, so you want to have concrete models before you move into the abstraction, but we need to start number lines right out of the chute in mathematics, elementary mathematics. This is a little bit different from when some of us went to school. number lines weren't as prevalent in foundational learning of numbers, at least in the instruction of school teachers. It wasn't our focus. It is now, and there's a lot of reasons for that. So we want to really help our students to understand how number lines work, because we're going to use them to figure some things out later on. So this idea of recognizing both the numeral and being able to count them out, label them, like know that that last rock that they stuck, or whatever counter you're going to use, know that that names the set, and know that every time we add one on, it gets to be this idea of more. We have more stones now. If I put another one on, we're going to have more stones. And so then eventually, I'm doing this very quickly, but eventually we want them to understand then that if they see this number 10 and they have 10 stones, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that's 10 stones. So we know this about this. And we also want them to know that if there's 10 stones in this number on the number line, will there be more or less stones if we have 9? Wait time is really important. So you don't want to understand or your child that question and just be like, hurry up. It's let them think what that might be. Will this be more stones or less stones? So this idea of more or less gets us into the second piece of the critical areas of focus for kindergarten on counting and cardinality. So we have counting and cardinality, which includes a lot of the counting principles that we've talked about. The second piece is including this idea of comparing numbers. So we just had a question about comparing numbers. If there's 10 stones in the 10 pile, are there more or less stones in the 9 pile? And you can have your little Dixie cup if you want to put your 10 in here. You could put a number of stones in the next one, and the next one, and the next one. Then they can use the actual stones for a proof. So if you have 10 stones here, and 9, and 8, and 7, and you say, okay, I'm going to have the 10 stones. If you have the 9 or the 7 stones, who has more or less stones in their cup? And let them guess at it with a solid answer. So here's my final answer. And if it's wrong, it's okay. We're playing. We learn through play. So let them dump them out and compare them. So now if we did want to compare, let's say that we wanted to compare two different groups of items. So let's say I have this group here, and then I have this group here. Now, another thing that we want students to be able to do is recognize, without even counting, have some recognition of number. So we might not be able to look at this number and say, there's 10, because it's all kind of in a chaos strategy here. It's just kind of laid down there. Now, if they count them 1 to 1 and they say that's 10, hallelujah, that's a great idea. They might also, and this is why arrays are valuable, they might organize them in a way that looks like this. So this is called an array. We have this row and this row. So we either have 2 rows or we have 5 columns of 2. 2 rows of 5 or 5 columns of 2. So we're arranging them in this kind of creative way. That's called an array. When you see numbers in arrays, a lot of times you can recognize that number a little bit more quickly than actually counting them up. As an example, if you look at this one. So this one down here, this might be a little bit easier both for us and for our kindergartners to recognize, because this is a group of 4. So if sometimes you can look at numbers and just automatically know what they are, that's a fluency indicator. So if we can look at this set of 4 and not really have to count it, but just know, I've seen so many sets of 4 that I know when something looks like this, has 2 arrays of 2, that's number 4. So They don't have to explain all that to you. They can. Like if you say how many stones are in this one, and they say 4 quickly, and you say, how'd you know that so quickly? And then let them explain whatever it is that they're thinking. Same thing here. How'd you know that so quickly that it was 10? Well, there's a group of 5 and a group of 5. No, they'll say it in kindergarten language, but that's a good thing for them to know. So another thing that we can do when we compare numbers, so we have this number 10 and this number 4, and in kindergarten for the critical areas of focus, one thing that we want them to be able to do is say which one has more and which one has less. Now I know we all, and eventually your students will too, work with a symbol. It's called an inequality symbol. We don't need to use those here, and I really am asking that you not use them here. We're talking about conceptual understanding right now, not an abstraction. So in abstraction, when I say inequalities look like this. You'll remember them. Probably you had some alligator stuff happening, but all of these are symbols of inequalities. So, but I'm going to put a great big X over them because we don't want to do that in kindergarten. Speeding your students along to use this notation is not like the most important thing right now. The most important thing right now is for them to really understand this idea of more than or greater than or less than or fewer than. Another piece that they need to know is same. So if we have 4 here, can you change this set? Put down however many stones you want so that they are the same numbers. So then they would be looking at this set and trying to match this set. What would look the same? And they may try to have it look the same just because of the array, having it look like the same array. They may do that. They may just count out 4 more. We don't know. And what the cool thing is about kids is what we learn from them is how they show us. So when they show us something, that's how they're learning. And so we want to kind of connect in to those pieces too. So this would be a same one. Another way to look at more and less, if it's a little bit similar. So let's say I have this pile of stones, and this pile of stones, and we want to know, we're going to compare, because that's one of the big ideas in kindergarten for critical areas of focus. We want to know which one has more and which one has less. So there are several different ways that your students can do it, and let them do it however they want. So one is they count each side. 1, 2, 3, 4, 5, 6. There are 6. So if they say there are 6, and they write down the numeral 6, then we know that they have this idea of counting cardinality. So that's one of the first critical areas of focus. So we know this. And then we're going to count this one. 1, 2, 3, 4, 5, 6, 7. So if they write the number 7 or the numeral 7, again, we know that they understand at least up to 6 and 7, that they can count, they have 1 to 1, and they have cardinality, which means they know that this means there's that many stones. Now they may or may not know, just by seeing the numbers 6 and 7, that 7 is bigger than 6. The assumption for adults is, well, yeah, 7's bigger than 6, but they might not know that yet. So that is that piece that we want them to know. We want them to know that 7 is 1 more than 6. Remember when we were talking on the number line, that 7 is 1 more than 6, and that 1 more is putting another stone on. So we have the exact same number of stones here, but 1 more here. Another way that they can do this with a comparison, again, so first comparison could be they just happen to know that 7 is more than 6. The other could be they could put it on a number line and show. Another one is to do a direct comparison of the items. So, and this really gets them to understanding this idea of comparing numbers. Now for little ones, you might need some graph paper so that they could put the stones in graph paper, but you don't have to do that. You can just have a match up. So this one matches with this matches with this matches with this, this matches with this, this with this, and this with this, and look what happens. When we have the 7 group, we have this leftover fella here, or gal, or he or they or she, he, they, she. And this one doesn't have a match. So what does that mean? That means just by comparing them, by looking at these items, not even looking at the abstraction of the numbers 6 and 7, but looking just at these concrete items, we know that this one has more because it has an extra one who doesn't have a match. So that's the idea of comparison. So comparison always used to be just they had to know which number was farther to the right on the number line than it is on the left. That's not this critical area of focus. We really want them to be able to compare numbers, and especially in kindergarten, between 0 and 10, and be able to tell which one has more and which one has less. I want to use one last tool that we've used before, and that is an egg carton. So I have this egg carton. Egg cartons are a great tool for kindergarten, first grade. Make sure when I use egg cartons with students, I make sure that they know that I cut off these last 2, because we also don't want them to think that 10 is a dozen. So, but when we have it cut off as 10, then we can see which numbers are more. So if we have, let's see, I'm just going to put some stones in here. This tool, this very simple tool, helps students to learn how to put numbers in an array, because you can see this array that these numbers are in. So it's looks like 2 rows. This row has 4, this row has 3, or you can look at these columns here. So you can say, okay, this is 6. Now, what about 4? Is 4 more or less than, this is 7. Is 4 more or less than 7? Well, let's see what 4 would be. If this is 7, 1, 2, 3, 4, 5, 6, 7. If I want 4, 1, 2, 3, 4, that means these can't be there. So if I'm removing some of these stones, that means that the 4 must be less, because I had to remove some of my 7. These are just little tricks and tools and items that are around the house that you can use every day if you want with kids. Like if you make a game out of it. If they're having cereal or if they're eating raisins, something like that. You use a tool that they become very familiar with. Because one of the other things, and we're going to talk about this in part 2, one of the other things is that we need students to really, when they think of 10, we need them to think of these 2 arrays of 5. Because that will help them when they start to do computations, which is addition and subtraction. And making 10s are a huge tool. So if you can use this 10 frame, this is called a 10 frame, this homemade 10 frame with your students, that will really help them out. So again, don't want to talk too long, but we are talking about critical areas of focus. This is for kindergarten. This is what we want students to make sure that they know at the end of kindergarten. So if your student's going into first grade, these are some things that we really need them to know before they get into that first grade year. We'll talk on the next session about part 2 of counting and cardinality, and do a little bit of operations with that. So if you have any questions, please post any questions to the Math Literacy Initiative Facebook page. We also have Instagram. Post any questions you have there. We'd love to be able to respond to some of the things that maybe your students or your children are going through and need some extra help with. So I hope you have a great week. Check out some of our other videos, and we'll talk to you soon. Go Bucks.